Hello class, this is a video tutorial on mathematical induction part 3. In this video we'll be looking at divisibility tests and induction. So before we continue, we need to really quickly go over of what divisibility is. If one number, let's say any number a, is divided by a different number b, except b can't be 0, and if it's divided without any remainders, then we can say that a is divisible by b. So for example, if we take a divide b and we get some number m, where m is a integer, we can say that a is divisible by b. So for example, 6 divide 2, we get 3. We can say that 6 is divisible by 2. 6 is divisible by 2. If we do 144 divided by 4, we get 36. That's a whole number. So we can say 144 is divisible by 4, and I think you get the idea. From this, we can also conclude that since a is divisible by b, as we've seen before, if we multiply both sides by b, we can say that a is the product of b times m. So m is any integer, and a, since it's divisible by b, must be the product of b times m. This will be an added step to the mathematical induction for divisibility. So using this, we can show that since 6 is divisible by 2, well, 6 can be made from 2 times 3. Likewise, 144 is divisible by 4. Then 4 times 36, it's divisible, and so on. So now, using mathematical induction, it is possible to prove numbers generated by very large expressions are divisible by some other integer. So for example, I've made a table here, and our large expression is 3 to the power of 4n minus 1. When we substitute 0, well, 3 to the power of 0 is 0. 1. Take away 1 is 0. 0 divided by 80 is 0. When we substitute 1, we get 80. 80 divided by 80 is 1. And if we continue this, if we substitute n is equal to 2 into our large expression, we get a very large number. And 6560 divided by 80 is 82. And so on. Now, before we go on, we need to understand that 0 is divisible by every number, because 0 divided by any number n except 0 is 0. So 0 is divisible by all numbers. Now back to this table. In the previous example, it seems that every integer n is greater than or equal to 0 for this expression is divisible by 80. Like in the previous example, we had this one here. It seems like this statement is true. In our example right now, it seems that every number from this expression is divisible by 80. Can we prove it? So using mathematical induction, we're going to prove the following here. It's kind of similar, but what it's going to be is we have some large expression. Is this divisible by 80? We're going to use mathematical induction to prove it. So for example, is this expression, so any number from this expression where n is greater than or equal to 1, is it divisible by 4, and so on. So since these examples are rather long, I'm gonna leave this to the next video, so I'll see you then. Best of luck.